So today we're going to look at naming ionic compounds that have polyatomic ions, so complex ions, but the number of oxygen atoms have changed. You're going to see that lots of those complex ions like sulfates, nitrates, phosphates, and so on, they all have oxygens. And there are also other ones on there that look a lot alike, but they have a slightly different name. So that's got to do with the way that the electrons can be shared. We'll just say it's a different oxidation state of one of the elements, but we'll get to that more in grade 12. But at the end of the day, we should be able to name these. And the way we look at it is when you look at the periodic table, the most normal or common form of the complex ion is going to end in the suffix ate. And then we're going to change that depending on whether oxygens have been added or removed from that normal amount. So we think of like nitrate, sulfate, phosphate, chlorate are all anions or complex ions that have kind of the most commonly found number of oxygens, or we'll call it a normal amount of oxygens. So the way, because I can't give you every possible option on the back of the periodic table because it would just be too big. But we did give you one, so you can find the pattern from one. So we're going to look at chlorate on the back of the periodic table. And if you look at the back of your periodic table, chlorate is ClO3. So I'm going to switch to the periodic table so you can see what I mean. So if we look up chlorate, so chlorate is right here. And it has ClO3. So the chlorate is the normal amount, so the normal amount of oxygen is 3. Now, if we try to find the other ones that kind of look like chlorate but are slightly different, that have just different amounts of oxygen, you're going to see what I mean. So let's find with one more oxygen. So instead of ClO3, it's ClO4. So here we are right there, ClO4. And notice the charge is still a 1-, but we now add the prefix to it called per. You can think of it as almost like it's hyper. It's above. That's what the per means. It means it's above chlorate. So it's like hyperchlorate, but we just don't say hyper. We say it's above, like it's per. Now, if we go back to ClO3, that's chlorate. Now we're going to go to ClO2. So we're going to look for ClO2, and here it is right here. So again, notice the charge is the same. It just has one less oxygen than chlorate. So chlorate goes from chlorate, ClO3, to chlorite. So we just changed the ending to an ITE ending. Now, the last one, there's only going to be this many variations that you're ever going to see. It would be removing 2 oxygens off of chlorate. So you're going to take 2 oxygens away from ClO3, so that would be ClO. And notice we say chlorite still, but now it's hypochlorite. So hypo means low. So if we're talking about like a diabetic person, when their blood sugar is low, they're hypoglycemic. And if their blood sugar is high, you could say that they're hyperglycemic. So hyper means above, and hypo means below. And the ate and the ite are the other 2 endings. So let's put this together into our notes so you can see a little bit better how this pattern goes. So chlorate is our normal. So imagine you take this and you make it the normal amount. So there's your normal. Now if we go up, so we plus 1 oxygen, we get perchlorate. And that would look like this, ClO4 with a 1-. So we've just, to go to the 1 oxygen more, we add the prefix per. Now let's say we're going to go down, we're going to take away 1 oxygen. So now we're going to end up with ClO2 with a 1-, and we change the ate to an ite. So it's chlorite. That's the new ending right there. That looks like oxygen. I'm going to put 1 oxygen, 1 oxygen. Okay, so now we're going to remove 2 oxygens. So I'll use, oops, pushed the wrong button here. We're going to remove 2 oxygens. So I'm going to remove another one. So we're going to take away 2 oxygens from the original. And that's going to look like this, ClO with a minus. So we had 3 oxygens, now we only have 1 oxygen. And this is called hypochlorite. And so we kept that ending, we just added the prefix hypo to it as well. So this is the pattern. So if we, like again, I can't give you every possible option on there, but we could follow this pattern for anything. So let's say we wanted to talk about, let's do carbonate. So if you have CO3 and it's a 2-, this is called carbonate. So now if you see something that is CO4 with a 2-, this would be percarbonate. If you had CO2 with a 2-, this would be carbonite. And then CO with a 2- would be hypocarbonite. Now it's important to note that the 8 is not always 3 oxygens. So if you go to, like, for example, sulfate, it's SO4. So persulfate would be SO5, sulfite would be SO3. So the specific number of oxygens doesn't matter. It's variation of the oxygens from the norm. So 8 being the norm, and the per is the max. So actually the prefix per also means fully. So if like you're perfect, you're fully fecked. I don't know if that really makes sense, but perplexed, you're fully flexed, I guess, or fully plexed. Anyways, that's where it actually comes from, but we just got to have this pattern down. So the rule is 1 more oxygen, we add the prefix per. 1 less oxygen, we add the suffix ite. 2 less oxygens, we add we add a prefix and a suffix, hypoite. So if we were to name these chemicals, we still name them the same way we have been. We just have to include these prefixes or suffixes depending on whether the amount of oxygens have changed. So again, when I look at this chemical, I see a metal, and then I see a non-metal group. So I would name the metal first, so that is sodium. And then if you're not sure what that is, just look it up on the table. Chances are the most common ones will be there, and NO3 is actually already there. It is just nitrate. So that one's nothing really new. But now we get to this one, K3PO2. So we have K3, that's my metal, so that's potassium. And then PO2 is the nonmetal group. Now, if you look on your periodic table, I don't think you'll find PO2, but we do find PO4. So PO4 is phosphate, PO3 would be phosphite, so PO2 would be hypophosphite. LiSO3, so Li's are metal, so that's lithium. And then SO3 is my nonmetal group, and that one's actually on the back of your table, so it's not one we'd have to figure out the pattern for. It's sulfite. Now, why is it sulfite? Well, sulfate is SO4, so 1 less oxygen is SO3. So going to my last one, zinc would be my metal, and the nonmetal group is ClO4, and we actually have that one on our periodic table. So it would be chlorate, but it's actually perchlorate because it's got 1 extra oxygen. So here's some try these ones. You can give them a shot, see if you can figure them out, pause the video, try them out, and then you can resume the video and see how you did. Okay, to name sodium, or to write the formula for sodium phosphite, I guess I should say. Na is a 1+, phosphite. So now looking on the back of the table, I don't see phosphite, but I do see phosphate. So phosphate is PO4, so phosphite is PO3, and it's still a 3-. So the formula for this would be Na3PO3. Okay, all the rules we've done still apply. So lead 2, that tells me the charge on lead is Pb with a 2 plus. Per sulfate, I don't know if that one's on the back. I don't think it is. So sulfate is SO4, so per sulfate would be SO5, and it's still a 2 minus. So this would just be PbSO5. Lithium silicate, so Li is a 1 plus. Silicate is SiO3. It's straight off the back of the periodic table. You'll always have at least one of the pattern, usually the 8. So now to put these together, I'm going to need 2 lithiums, SiO3. Now going the other way, we're going to write the name. So I'm going to write my metal first. This is magnesium. Now we got to know what PO5 is. We actually did this one earlier, I believe, but if we don't know, we look up on our table. There's phosphate is PO4, so we got to add an oxygen so it becomes perphosphate. And then the last one, aluminum. And NO3 is nitrate, so NO4 would be pernitrate. And that's naming with varied oxygens.